Okay, so today we're going to talk about geometric sequences and how to write both a recursive formula and an explicit formula for those sequences. So a geometric sequence varies by a common factor. So the other sequence that we talked about earlier is arithmetic, and arithmetic factor differed by a common difference. So we were adding and subtracting. So with a common factor, we're multiplying. So you can be multiplying by a whole number or by a fraction. So really it's multiplying or dividing. So if we're looking at this first sequence, 124, and it wants us to write a recursive formula for the first part. So for the first part, a recursive formula always starts by listing our first term. So the first term, or a sub 1, is 100. Okay? With a recursive formula, the second part is identifying what the nth term will be, or that nth could be 100, it could be 1 million, it could be whatever. And in recursive, that nth term is always written based on the previous term. So the previous term would be n minus 1. So to the n minus 1 term times that ratio, whatever that factor is, so times r, is going to be what our recursive formula is. So we need to figure out what their r is. Because it's a common factor, we're going to put the second over the first, the third over the second, to figure out if we've got a common factor. So the second over the first would reduce to 1/5. And then the third over the second would again reduce to 1/5. So we know that r then is 1/5. If we know that r is 1/5, then we can write a final answer for my recursive formula, which is a sub 1 equals 100, a sub n equals a sub n minus 1 times 1/5. And there's your recursive formula. Now, recursive formulas are not nearly as nice because you always have to have that term before in order to get the next term. But explicit formulas are way nicer because you don't have to have that. So the formula for an explicit geometric sequence is a sub n equals a sub 1 times r to the n minus 1. So it's the same parts as the recursive formula, but it's just stuck all together in one formula. So this would be a sub n equals, our a sub 1 was our first term, which was 100. Our r is that 1/5 number that we've used before, and then to the n minus 1. So that is our explicit formula for this geometric sequence. To find the fifth term, like it's asking us to do, we're simply going to plug in a 5 when we see that n. Okay? And then I just evaluate it. So I follow order of operations. So we've got 100 times 1/5 to the 4th. So you could grab a calculator at this point. I don't have a calculator handy, so I'm just going to do it by hand. So 1 to the 4th is 1, and 5 to the 4th is 625. So this would equal 100 over 625, and I can reduce that. So a sub 5 equals, divide top and bottom by 25, and you get 4 over 25. So my fifth term in this sequence is 4 over 25. Hopefully that lit up a little light bulb in your head about geometric sequences.